We are continuing on in our regression tutorial. We're going to be looking at building a regression model to explain California housing price data, which is from the 2000 census. This part of the tutorial is based off of Roger Biven's spatial regression examples on rspatial.org. In our assignment, we will be walking through a similar project or working through it using Canadian census data. All of our files that we have been provided share this GeoID variable that we can use to join data together. And we have three files that we'll be working with. The one file that is a CSV, which is the average house price per census tract. The census tract attributes files. This provides other attributes about each census tract, describing the household, for example, the average number of bedrooms, and then a file that we will read in later, which is the polygon file, providing us the spatial boundaries. Now, we will read in the housing price information. So I just selected it and then I ran that specific chunk of code. And it tells me I read in a GeoID as a numeric and a house value as a numeric. And then this file was a little tricky and it wasn't parsing the column types correctly because it wasn't reading down far enough to estimate what type of column it was going to be. So I've increased the guess max to 9,500. And it allows us to read in the house attributes data correctly. And now we have our two files read in. So let's take a look at each of these. So we can look at the house prices. And there we have our tibble. We have 7,000 rows. We have two columns or two variables. And we can also look at our house attributes here. And we have 7,049 rows and 17 columns or variables. Now, we'll notice that we have this label that provides us with a census tract number, a census tract name, and then the state that it's within. We have the number of housing units and number of attributes about the housing units or the census tracts. Okay, so for example, the median household income within the census tract, what the population is within the census tract. Now these two files that we just read in are stored in different variables, and really we want them combined to work with them. With dplyr, we have a few different ways of joining data. I will let you read through this section. Now that you've read through this, we're really interested in our regression model to join our data, but we want to join it in a way that we don't have any missing data, because any row with missing data in our regression model will be excluded from our regression modeling. So we'll just make sure we don't introduce any null values. So we will call this California underscore CTS, okay? And we will do the inner join, and we're going to join the house prices with the house attributes, and we will join those by the column GeoID. So I will run that, and then we will view our new tibble. And we can see that our tibble has 7,049 rows, 18 columns. So we had two columns in our first house prices variable or tibble, and then in our house attributes we had 17 variables, but each of those shared the GeoID. So we've only stored that once, we haven't stored that twice. So we now have our house values with all of our additional variables. Now we have another file that is the definitions of each of these variables. So we can read that in as well, and it was stored as a text file, and a text file which was actually a CSV. So we can read that in, and it just gives us variable name and then the explanation of the variable. And you can keep that for reference as you're moving forward. Our next step is some data management here. Okay, so we have our label variable, but we are actually going to want to subset based on that label variable just the census tracts that are within the San Diego County. There are 7,049 census tracts within California, but we're only going to be interested in those within San Diego County. Now, one way we can do this is by splitting up our label variable into 3 new variables. And we will term those CT, which is the census tract number, name and number, the county, which is we're going to be looking for ones that are San Diego, and then the state. So we will then also remove any extra spaces before or after a county name, which can occur when we're splitting strings. So if we split it on the comma and someone adds a space before the comma, it will add these extra spaces that make it difficult to filter. So what we do is give a variable name here, call it San Diego. We'll work with our data set or our Tibble California CTs using our pipe operator and the separate function. We'll separate label, and we'll separate it based on the comma, and we'll separate it into 3 different variables. So that's splitting our data, and then we want to mutate a variable, and by mutating it, what we're doing is using the string trim function. Okay? And we're going to give it our variable name, and we're going to remove extra spaces on either side. And from there, we can then filter our data to just having San Diego County. So when we run this set of operations, and we read in our San Diego Tibble, we can see now we only have 605 rows. All of these rows are different census tracts within San Diego County, and they're all within the state of California. And we have 20 columns now in our case because we've added additional variables. We are going to do some data creation here, and we want to modify some of our count variables into ratio variables. So they vary more reasonably as the size of the census tract changes. We can think of this as when we normalize or standardize our data in our choropleth maps. And we're going to work with 3 of these, which are the number of mobile homes, the number of houses with bad plumbing, and the number of houses with bad kitchens. So just to review, we can go look at what those are. So N bad kitchen is the number of houses with incomplete kitchens, and N bad plumbing is the number of houses with incomplete plumbing. Now, based on our kind of ideas that both these variables could have a negative relationship with the housing price within a census tract. So we'll use the mutate function, and if we can't recall what the mutate function works or how it works, we can just use our help. And here it's saying there are, within the plier package or within the dplier package, so we have 2 variables that share the same name in this case. Here we're going to be using the one within the dplier package. And sorry, not variables, but functions. And here it adds new variables and preserves existing variables in our data set. And we can add some sort of function onto that to create our new variable. So in this case, we'll give our new variable name. We'll call it P, as in proportion, and use the same naming conventions. And we'll divide the number of units, so mobile homes, the number of houses with incomplete plumbing, or the number of houses with incomplete kitchens, by the number of houses within the entire area, within the entire census tract. And we're just combining these mutate functions with the pipe. When we run this, we can call this new Tibble-San Diego ratios. And let's just take a look at that. San Diego, and we'll look at the ratios table we created. And if we go over to the end, we can see the proportions that we created. Now we can see, as a proportion, there's very few mobile homes across most census tracts, but the number of bad plumbing or bad kitchens are existing in most census tracts. Now we'll stop it there, and we will work through some of our potential predictors in the next video.